Hello, Mark Sudduth, HurricaneTrack.com here with a Hurricane and Hurricane HD special end of the season broadcast. I'm going to go over the busy hurricane season that we had. You know, it all started, before things got started, really, with the predictions. Colorado State University and NOAA, the National Oceanic and Atmospheric Administration, I'll talk about their two forecasts. In the early part of the year, of the season anyway, May and June, when these forecasts came out. Colorado State June 1st, NOAA's on May 24th. Both of the agencies were thinking that it would be either a slightly below average season with less than average activity, or maybe right at average, maybe 10 named storms, 12 named storms at the most, 6 hurricanes perhaps, and 2 major hurricanes. That was the thinking before things got started. Here's NOAA's press release page back in May. NOAA predicts a near normal 2012 Atlantic hurricane season. As we know, things turned out quite differently. We had 19 named storms, well above the 100-year average, 10 hurricanes, which is also above the 100-year average, and only 1 major hurricane, which is below average. Now, why did we have only 1 major hurricane? What was the reason behind that? Well, basically, we had a very interesting year because most of the development, anything you see here in yellow, right there, this is from my colleague Mike Watkins, who has a company called Hurricane Analytics. He partners with us, and he has plotted all of the Hurricane Center's forecast this year and the different strengths of this season's tropical storms and hurricanes. And anything that you see here in yellow is a hurricane at hurricane strength or above, hurricane intensity or above. And you can see that all of the yellow seems to be out of the deep tropics. Only a small little area over here where we had hurricane intensities taking place down in the deep tropics, that area south of 25 degrees north latitude, really. And a lot of folks consider it south of 20. The deep tropics down here between Africa and the Lesser Antilles, the Caribbean. Look at all the yellow up in here. We had a lot of development, peak intensities as it were, outside of the deep tropics. Why was that? Basically, we had a layer of dry air or stable air. Another way to look at it is a lack of instability, the ability of the atmosphere to be unstable and therefore creating deep convection. That was void this year all throughout this main development region. That's why you see lots of blues and greens in here where we had development genesis, the beginnings, but very few yellows. Some over here in the Western Caribbean, which is typically a very unstable area, lots of deep ocean heat content there, and therefore we had a pretty significant occurrence in the scheme of things of hurricanes occurring there, with Ernesto in the early part of August coming into the Yucatan, Belize area, and then of course Hurricane Sandy at the end of October, another hurricane forming down here in the deep tropics. Everything else, Isaac reaching its peak intensity north of 25 degrees of latitude, which is right there. Look at everything else. We had Nadine that was out here, Michael, Chris that was the first hurricane of the season, and then of course Sandy maintained hurricane intensity, at least wind speed wise, and structurally, that'll be debated for a while, right up until landfall near Atlantic City, New Jersey at the end of October. So let's take a look back. We started things off before the season technically began. May 19th was Tropical Storm Alberto. Not a real big deal. It paralleled the Carolina coast and moved on out to sea as a trough dug in and kicked it out. We thought, well, maybe that'll be the way things go this year. Very similar to 1997 when we had a significant El Nino. The forecast was for an El Nino to develop, and that typically brings a lot of development out of the tropics, out in this region, and the storms are small, weak, and they tend to curve out to sea. Now, once in a while in an El Nino year, you get a rogue storm, if you want to call it that, sort of an outlier, such as Andrew, a very memorable hurricane in U.S. history. We were hoping that we wouldn't see anything like that this year, the 20-year anniversary of Andrew. Sometimes you do just get one of those one breakaway storms in an otherwise fairly innocuous season, that can really cause a lot of problems. So when we saw Alberto form, and it was off the coast of the Carolinas from sort of an old frontal boundary and pre-existing disturbance, and the fact that it moved on out to sea rather quickly, typical of El Nino years, we thought, all right, well, this might very well be a fairly tame season after all. Then, not long after, Tropical Storm Beryl formed, again almost in the same genesis area here, right off the southeast coast, but it moved inland as high pressure built over the western Atlantic, and it hit Jacksonville, Florida from the east, an almost impossible feat. You don't see hurricanes and tropical storms hitting Jacksonville, Florida along 30 degrees of latitude there perpendicularly, if that's a word, but you get the idea that it came at the coast at a right angle there, coming into the coast instead of coming up the coast like we see usually. So that was an unusual event, and Beryl almost became a hurricane. A couple of screenshots from our intercept of Beryl. We posted video blogs to Hurricane and Hurricane HD from the field, and this is an iPhone picture of our laptop inside of our Chevy Tahoe with all the hurricane tracking equipment on it, and you can see it had very good banding structures to it. Beryl was trying to become a hurricane as it made landfall here in northern Florida. It had the warm Gulf Stream waters to work with. It just didn't quite have the support to become a hurricane, fortunately. It did cause some beach erosion, some trees down, minor power outages, but it was a substantial event because of the time of year that it occurred, the fact that it did become a pure, warm core, no question about it, tropical storm, and it almost became a hurricane and hit Jacksonville, Florida. The maximum winds that we recorded on our vehicle's anemometer, 58 mile per hour was the gust. This one on the left is sort of your instant wind reading. It goes by every second, and then the peak gust until we reset it is recorded here over on the right. We were in an area near Fernandina Beach in one vehicle. There were higher wind gusts with Beryl. As you can imagine, you cannot have, there's just not enough money out there for it, unfortunately, dozens and dozens of weather stations with accurate equipment to measure the full wind field of a storm or a hurricane, and we do the best we can with what we've got. Another screenshot, it's hard to tell, but definitely that sheets of rain, that tropical rainfall coming in, gusty winds when the rainfall would hit those rain bands. It was a pretty decent event for the area, considering it was a direct hit from a tropical storm and a strong one at that, 70 miles per hour in some areas around that circulation at the end of May, before the season even began. Then, as things moved along, we got Chris towards the end of June, and you're going to see a pattern here that the end of each month, with almost few exceptions, we had this period where we would get these bursts of activity, following closely the Madden-Julian oscillation, where we had a 30-day to 40-day cycle of bursts of activity and then a few weeks of nothing. And so at the end of May, we had Alberto and Beryl. At the end of June, we had our first hurricane with Chris here, well out in the northern Atlantic, north of 40 degrees latitude. Very, very unusual to have that happen, but waters were warm enough, conditions were favorable, and we had Hurricane Chris at the end of June. We also had hurricane watches put up, or at least the threat of a hurricane. I don't think watches were ever issued, but we thought that Debbie, and this was an interesting situation, also at the end of June, could become a hurricane, as you see here, and threaten southeast Louisiana. The European model was showing that a pretty strong area of high pressure would develop and send Debbie to the west. Some of the models were even suggesting a track towards Texas, and that would have been really bad. It would have had a lot more time over water. But then, the very next advisory, it changed, and the GFS was favored, which showed troughing coming in just enough to weaken that high, and Debbie instead came inland over the panhandle of Florida. It produced some tornadoes, lots of heavy rain, some severe weather, and gusty winds along the coast, but it did not come into southeast Louisiana. That's one of the rare times. This is forecast advisory number 5 for Debbie. This is the very next one. You don't usually see such a dramatic shift in the forecast track. Very, very unusual, highlighting the difficulty of understanding the track forecast, even in this modern era, where we have supercomputers handling this stuff. you can have huge discrepancies even now. And boy, it's a really good thing that conditions out here were not ideal, because this could have been a short fuse situation had Debbie tried to intensify rapidly before landfall. A big problem if that ever happens. Moving right along towards the 1st of August, this was the tropical wave in the envelope of energy that became Ernesto. And at about this same time, Ernesto forecast to go through the Caribbean. A lot of people were wondering, will this come on in to the Gulf and threaten the Louisiana, Mississippi area? Could it maybe get caught in a trough and come up the East Coast? Or will it just go on into Central America, more typical of a La Nina season? And by this time, the El Nino really wasn't coming around. The Pacific was not warming as projected by the big climate models, and so we were looking at a low latitude system coming in. This was fairly low in latitude here. This is 10 degrees north latitude there, and Ernesto was forecast to kind of track right along. And it eventually, of course, came into Belize, as we know. At the same time, early August, Colorado State and NOAA revised their forecasts. Obviously, at this point, we'd already had 4 named storms. So by early August, the forecast projection was for 14 named storms, 6 hurricanes, and 2 intense ones. Those were also mostly on the low side for forecasts. As you know, we ended up with 19 named storms, 10 hurricanes, and only 1 major. So we were low in the major hurricanes department, well above on the hurricanes, and well above normal on the named storms. So looking at Ernesto, very tropical in nature, had very good banding features with it, a large envelope of energy, but there was still this sinking kind of dry air in the mid-levels that made it difficult. These storms had to really work hard to intensify, and that was good news because it kept them from becoming very, very intense hurricanes. You think about the track that Ernesto took across all this open water here, where there's very high ocean heat content along its path. It had other elements of the atmosphere that it had to battle, luckily, that kept it from becoming a very intense hurricane. And, you know, in other years we've seen it where that was not the case, where things really did explode. You look at 05 with Emily, I think it was, that passed through this area. And then, of course, Wilma at the end of that season becoming a Category 5 in the same region. Just amazing how different the Atlantic Basin can be from year to year on what kinds of storms and hurricanes it's able to produce and support. So the track of Ernesto, as you know, right on into the Yucatan, and it stayed buried here over the extreme southern Bay of Campeche and was never a threat to the northern Gulf Coast or Texas. Moving on along, after Ernesto, there was Florence, open ocean storm. It fizzled out due to hostile conditions out in the Atlantic, and it never amounted to much. Then we had Gordon, which passed through the Azores. It was a hurricane at one point, and things just kept moving right along. August was fairly active as we went through this MJO pulse that kind of hung around for a little while longer. Conditions basically stayed favorable as the El Nino fizzled in the Pacific. Things stayed pretty active in the Atlantic. And so after we had Florence and then Gordon, we had Helene, which came into the Caribbean. It too was able to only become a tropical storm. It struggled and luckily didn't amount to too much. But then there was Isaac, and it looked like it could really be trouble. It formed early in the morning on August the 21st, the tail end of August, headed towards and through the Caribbean. Lots of people in Florida were quite concerned about it. There was even some indications that it could turn up the East Coast and threaten the southeast United States. A look at a satellite picture, tropical weather outlook map from the Hurricane Center at that point. Large envelope of energy associated with what was Isaac, and as we know now, it came through the Caribbean and eventually on into, actually that's the wrong track, but the end result is correct, that it came into southeast Louisiana. The GFS, though, had some problems with it, though it's not real bad. What you're looking at here is the August 21st forecast for 168 hours out, and it's a week away, and it was still way out here east of the islands, and the GFS showed the system coming in near Sarasota, Florida. Of course, we know now that it came in down here in southeast Louisiana. That's a big difference, I think, obviously. But from a week away, if you were to say that this region could expect hurricane conditions possible, in other words, look out, there might be a hurricane heading your way, that's not bad. That's not a giant geographic area. And these people would have had well planned out, what to look out for, because the GFS was suggesting that this could come through and impact this region. Point being is that the global models a week ahead of time indicated that somewhere along the Gulf Coast, in a fairly small area, I mean, you're not talking about 3,000 miles of difference here. As the crow flies, Sarasota to Grand Isle, Louisiana, for example, is not that far, especially hitting it from a week out. Isaac, not Ernesto, coming in through the Caribbean here, as you can see, this is August 23rd. Huge envelope of energy. A lot of people up here were watching. We had the Republican convention in Tampa, and that was obviously a big concern that this might affect that region. As we moved on through time, the GFS finally started to shift as we saw the high pressure area building over the Atlantic, nudging it farther and farther to the west. GFS indicating maybe a Pensacola landfall. The Hurricane Center, kind of following along with the global models. It was a toss-up between the Euro, which was showing a more westward track, and the GFS, which was trying to turn it into a weakness in the atmosphere up here over the southeast. Isaac, forecast to come in near Mobile, Alabama, on this forecast issued on August the 23rd. So that's a 5-day forecast error that's not real bad, because the eventual landfall, of course, was just right over here. So that's not that far away as the crow flies, a straight line from 5 days out. Wow, that's pretty good. And then, of course, as we know, Isaac, I got it right this time, came on into southeast Louisiana. It brought a significant storm surge, in some areas 12 feet, and southeast Louisiana, portions of Mississippi, especially the western areas, Hancock County, got a substantial storm surge, more damage, more flooding. A lot of people were caught by surprise, they said. I think they were focused too much on that being a Category 1, and they were not reading the headlines that over and over and over and over, it was put out there many times by the Hurricane Center. It was in the app here. We were talking about it on HurricaneTrack.com. Don't worry about the category. There's a dangerous storm surge coming. And storm surge is damaging, and it's dangerous and lethal. And that was the headline. And still, people somehow ignored that and thought, well, it's just a Category 1, so it can't be that dangerous. And indeed it was. It caused a lot of property damage again, especially in southeast Louisiana, and unfortunately, the loss of life. A couple of screenshots to show you photographs. We set up a remote camera system to monitor Isaac's arrival. This is August 28th in the Gulfport Harbor area. You see the parking lot and the sidewalk here. The next day, now we have waves coming in through the same area, 3 to 4 feet deep of ocean water from the Gulf, the Mississippi Sound there. Our remote technology documenting what Isaac did. This is a shot of the St. Louis Bay and NOAA's Hurricane Sentinel that's set up out there. It looks like the Atlantic Ocean, doesn't it? It's the St. Louis Bay, or Bay St. Louis, whichever way you want to say it, as seen from the Bay Waveland Yacht Club. We set some equipment up out there. We were hoping to put equipment on that tower, but let me zoom in on that with our secondary camera here. Look at that. Quite a dramatic picture. Rarely will you see the St. Louis Bay like that. Obviously, in a hurricane, you will. We were hoping to put in a remote cam of our own out there, but it was too choppy to get there the day before Isaac's arrival, and so we had to put the unit on the Bay Waveland Yacht Club, and it did very well in capturing data and images for us. A shot at the hurricane warning flags down at the Gulfport Harbor. Move through some of these slides. Overall, Isaac, not the most damaging of the year, but certainly one that captured a lot of headlines due to the early forecasts of it potentially impacting Florida. But again, a lesson in not paying attention solely to the category, but more those weapons of mass destruction that hurricanes bring with them. And that's exactly what they are. The wind, the storm surge, the rain, and the tornado threat and downburst winds. any one of those particular effects can be deadly and cause significant damage. Moving right along, then there was Joyce. Towards the end of August, things stayed really busy. Joyce stayed out in the open Atlantic at least, maybe teasing Bermuda, putting them on edge that it could be a problem, but it never really was. Then there was Kirk. Lots of different jokes about Kirk out there from Star Trek fans, of course. But it too, in the open ocean, way out in the middle of nowhere, reaching its peak intensity. I mean, look at this. The forecast was for it to be a hurricane here, once again, at 40 degrees latitude and north. Unbelievable. Just a very different type of season than we've seen in recent years. Luckily. Then we had Leslie, and Leslie was destined to really impact Bermuda here. Looks like it could have been a major hurricane hit for Bermuda. Luckily, it came on up and bypassed Bermuda to the east, enough so that it kept the worst of effects away from Bermuda. Michael was the season's strongest hurricane, reaching its peak intensity, you guessed it, way out here in the open Atlantic, well north of the deep tropics, where you would not expect that to happen, but indeed it did, and it was the season's only Category 3 hurricane so far. This is a shot of the western basin. This is September 7th, near the peak of the season. Look at all of the dry air. That's represented by the darker bronze and black colors in here, and certainly over the Gulf. Very stable air when you see that. The moisture and humidity is the white here, the water vapor. That's what we're looking for in this picture. And the typical breeding grounds were, even out in the tropical Atlantic, drier than normal. And I mentioned that at the beginning. That was a big characteristic of the season this year, and kept a lot of the activity from being strong down in the deep tropics. And you can see that on this water vapor shot on September the 7th. Thought I would throw that in there as an example, showing very clearly how hostile the season was, and yet we still managed to squeak out 19 named storms. So then there was Nadine. Its track was just all over the place. You remember that, and it was ridiculous. Lasted for almost a month. Then we had Oscar, way out in the open ocean. It was no big deal at all. Patty, yeah, had some potential. It formed in some of the areas where Andrew got its act together. Had things been different, and Patty come through like this, it would have been pretty reminiscent of Andrew back in 1992. I bet that was going through some people's minds, that if conditions were more favorable. Luckily, even though this was north of 25 when it finally got its act together, conditions through here were just too stable. Wind shear in the atmosphere and that dry air layer in the mid-levels, the humidity level was too low, and you just didn't have that juice that we had in 2004 and 2005 as an example, and even in 2008. Really, again, indicating how different and variable the Atlantic Basin can be from year to year. Next, there was Raphael, and it went through the Northeast Caribbean and passed close to Bermuda, but not too close. They were in the sights of quite a few storms this year. Luckily, no major problems. Raphael eventually went on east of the Canadian Maritimes and Newfoundland. And then there was Sandy. Obviously the biggest story of the year on a lot of levels. Sandy at the end of October in a favorable Madden-Julian oscillation pulse. Large envelope of energy coming in the deep tropics. And finally, for the first time in the year, the humidity and the water vapor and the energy down here was substantial. The dry air had sort of mixed out, and Sandy was able to become a very strong hurricane hitting Jamaica, and then eastern Cuba here. Had this mountainous area of Cuba not been in the way, Sandy would have gone on to become a very intense hurricane coming into the southeast and central Bahamas here. Luckily for those folks, the mountains of Cuba were there. As it was, Sandy was very strong, almost a Category 3, and maybe it'll be upgraded to a Category 3 in the postseason analysis. Stay tuned to see if that happens. A couple of interesting points. We know now the GFS was suggesting Sandy would curve on out to sea, hand it off into the westerlies, as is typical with cyclones that time of year at the end of October. But the Euro had a different idea with its model physics, suggesting that there was already low pressure sitting out over the Atlantic, and that there would be enough high pressure building in between it and Sandy to keep it trapped along the east coast, and then a huge area of high pressure would build down out of Greenland and block Sandy from turning out and then actually retrograding it back in towards New England or the Northeast. And that is, in fact, what happened. As we now know, the Euro was right 8 days out with picking up on the large-scale weather patterns. And there it is, the historic track, very similar to what Hazel did, which was something like this in 1954. It got trapped, high pressure built in, and sent Hazel into the United States, into North Carolina. So a similar type track with Sandy here, that it came up and then came back with two different attempts to get back to the coast. As weak area of high pressure built in here, and then another area of high pressure way up here coming out of Greenland. And history was made with this very, very big disruptive storm coming in at almost a perpendicular strike to the coast. A couple of images for you. This is from the North Carolina Outer Banks from a remote camera that we set up. This is not snow. That is storm surge affecting the coastline there. Our camera timestamp, you can see this is all froth and foam as the ocean comes in, eroding the dunes, and it washed away a lot of streets, especially Highway 12 south of Oregon Inlet. Damage to property, a very bad situation along North Carolina's Outer Banks, and this is with Sandy passing 200 miles plus to the east. Up in New Jersey, the top image from the Google Street Level Maps, Belmar, New Jersey. This is Ocean Avenue on a very nice day. This is the day after Sandy. I took this picture myself. Lots of destruction, 2 or 3 feet of sand, the road damaged, and in some areas houses in the street. You've seen the pictures. Sandy, very disruptive up in that area. Another remote camera on our wind tower that we set up at the Monmouth Beach Beach Club. Large parking lot that would be filled with cars as people go to the beach club during the summer and enjoy the boardwalk and the beach out here. This at 10:13 in the morning on the 29th, and this at 5:10 in the afternoon the same day. My tower that I set up being taken out by the surge. This is water 2 or 3 feet deep streaming through here, large pieces of stuff coming in off the ocean, debris knocking down everything, including my wind tower. We actually lost it. This is one of the last images that the camera took before it was wiped out by this damaging storm surge up there. Why was it so bad? I talked about this on the video blogs for Hurricane, Hurricane HD, and on our app, Hurricane Track, and on the website. For the general public, we wanted people to understand that if Sandy was going to curve in like this, like the forecast showed, you would have onshore flow, first of all, from the wind field, the counterclockwise rotation, but you would also have the hurricane, the storm system, pushing the water ahead of itself into the New York Bight up here, B-I-G-H-T, and that is very similar to what we saw in Texas. And I talked about this on the video blogs, that the coast of Texas is a similar shape, and Ike came in and pushed all that water into the coast of Texas. Sandy did the same thing, and the water had nowhere to go. So you put the water levels up down here in the Delaware Bay, up here through Long Island Sound. We'll take another look at that in a minute. Into the Raritan Bay up here along the beaches of southern Long Island, and then of course the coast of New Jersey. What else was going to happen? You had the continental shelf out here. This is very deep water. Sandy made that turn and headed towards the coast, and it just literally blew and pushed the water in the direction that it was moving, and it had nowhere to go. In the case of Long Island, and then again what happened here along New York City, you had that easterly flow pushing Long Island Sound down into this area where everything gets pinched off, and at the same time Sandy is pushing the water up from the south and east into the New York Bight area, into the Raritan Bay. Then it flows in, everything starts to rise and gets forced into one area, so that Brooklyn, the Rockaways, into Manhattan, the World Trade Center site flooded, subways flooded. We saw it, and yet the center was nowhere near this area. The center came in down here near Atlantic City. The center didn't matter. This did not have an eye wall in a classic hurricane where you could see that center coming in like Katrina or Charlie or Ivan. This was a large wind field that was piling up the water all across the area, and it was only a 75 to 90 mile per hour wind field that did this. It is possible, like in August or early September, that you can get a real run-of-the-mill, classic hurricane with a large wind field coming in with 130, 140 mile an hour winds. That is not out of the realm of possibility, and you haven't seen anything if that happens. Sandy will be absolutely nothing if we ever get a system like that, and the worst case is something coming in with a very large eye and a very large wind field, and it's moving just to the west of north, coming in across Sandy Hook like this. Sandy, not the worst case scenario, believe it or not. That full moon that we had Monday night, the 29th of landfall, didn't help, but boy, you get a true hurricane in the middle of the season with a large wind field and a much more intense structure with it, focusing that storm surge into an area like the New York Bight near New York City and the Raritan Bay. Then you're talking about a massive potential for loss of life. Sandy, hopefully a wake-up call for people in that area. Next, Tony. And Tony was just out there, didn't do anything, and that was it. 19 named storms, 10 hurricanes, 1 intense one or major. Maybe we'll add a second one if Sandy is upgraded to a Cat 3 just before it came into Cuba. So what about next year? There are climate pieces of the puzzle that we can look at. And this is yesterday's, November 29th, sea surface temperature anomalies map, the departures from normal. Notice the Atlantic Basin, much above normal out here between Africa and the Lesser Antilles. Now the Western Atlantic and the Caribbean below normal. I'm going to be watching this area real closely to see how this reacts through the winter and into the spring. We may have a different type of season next year. You remember how much I talked about the variability in Atlantic Basin characteristics year in and year out? We probably will see a different season next year where we get more development down here with these long track hurricanes and they're intense in the deep tropics rather than the development up here where the maximum intensities are reached north of the deep tropics. The other thing to watch, the Pacific's dotted with some warm anomalies, but overall, it's basically the warm side of neutral. We never got to the full El Nino, the abnormal warming of the equatorial Pacific that was forecast by the major climate models. We will be watching that too. If we get more cooling out here that we're seeing now, then we could have a true neutral pattern, or maybe even a weak La Nina, where the water temperatures out here are cooler than normal. Then next year's hurricane season for the Atlantic Basin could get really, really interesting. And you don't have to have another big year of 19 named storms, even 12 to 14 named storms with 4 major hurricanes happening. If we were to see that, it could be a very destructive year. We just don't know. And the bottom line is people need to be very prepared all the time and try to understand what hurricanes can do, even Category 1s. The battle against losing against hurricanes is, that battle is won in the off season, not when they come knocking on your door. So looking at the El Nino, back to topic here, the subsurface waters, we're looking at a cross-section. This is the eastern Pacific, the western Pacific, the surface of the Pacific, and several hundred meters below. So this is kind of like a CAT scan of the Pacific Ocean, if you will. And you can see all this warm water anomaly that was in here back in July. And then in August, you can see it remarkably faded out. By September, it was definitely gone, and we went to, certainly neutral conditions. A little bit of a warming tried to come back in October, but then a very cold pool starts to set up here in the eastern Pacific. This is something that we can watch on a monthly basis as we get closer to next year's hurricane season. And I'm actually going to be talking about this kind of stuff once a week in the Hurricane and Hurricane HD video blog series in the off season. So be sure to check the app once a week for a video update on what's going on across the globe as far as these bigger climate puzzle pieces. Some of the different models, this is the Australian Poema model for the El Nino Southern Oscillation, or ENSO, and it's forecasting a gradual decline in sea surface temperatures in the tropical Pacific to very near neutral, which is right there. On the other hand, the American-generated CFS, or Climate Forecast System model, we go into La Nina territory and then come out back towards El Nino. I don't think that's going to happen. It didn't happen this year. The Euro also kind of mixed, and it doesn't have a mean in here. You have to kind of put it in yourself. So maybe something like that. I think we'll be right around neutral, maybe just a tenth or two of a degree warmer than normal, but not El Nino threshold, which is about 0.8 degrees Celsius above normal and higher. I think the odds are that next year we'll have a neutral Pacific, maybe slightly warmer than normal. Hey, maybe we'll have a La Nina. But as long as you don't have these overwhelmingly warm or overwhelmingly cold where it really shocks the system, then there's really not much of an effect coming out of the Pacific to hinder tropical Atlantic development. And the main thing is, if you have a very warm Pacific, all of that rising air spreads out across the tropical Pacific, and then it sinks and dries in the Atlantic basin and creates wind shear and warming, drying air. And if that's not present, then we typically have a more favorable pattern in the Atlantic basin. So stay tuned. We shall see what happens for next year. Again, I am Mark Sudduth. This has been a recap of the 2012 season. Hopefully you learned something. Things seem to have gone really well in this presentation. I got it right on the first take. Have a great off season, and again, don't forget, check the apps, whichever one you have, once a week. Usually every Monday I'll try to put something in as we just take a peek at what may be happening for next year as we go through the cold winter ahead. It gives us something to, I don't want to say look forward to, because nobody looks forward to hurricanes. Outside of tracking them, maybe it's interesting, but certainly not their bad effects. But this will give us something to do in the off season. So again, Mark Sudduth, HurricaneTrack.com. That's my website. It's been a real pleasure and a privilege to be able to produce these videos for you again this year. Watch them during the off season if you will, and then I'll see you again on a regular basis starting next May.